Good day, ladies and gentlemen, and welcome to Spinnaker's webinar. Should JDA sequencing be the next step in your supply chain journey? All lines have been placed on a listen-only mode, and the floor will be open for questions following the presentation. To submit your question at any time during the webinar, you may use the chat box located on the lower left corner of your screen. Simply type your message into the box and click on the send button. If you should require assistance throughout the conference, please press *0 on your telephone keypad to reach a live operator. At this time, it is my pleasure to turn the floor over to your host, John Sharkey. Sir, the floor is yours.
Thank you, Dagmar. Good morning or good afternoon, everyone, depending upon where you're at. Thank you for joining us for our webinar on JDA sequencing today. We've seen a little bit of a resurgence. JDA sequencing is a solution that's been around for many years. But one thing that we're seeing is as companies kind of move through their supply chain maturity journey and start to become more stable on demand solutions and master planning solutions, which is where kind of most companies start, they're kind of revisiting the idea of how do we close the loop in the factories. And so that's what we wanted to come and talk a little bit about with you today. Just as quick introduction, so I'm John Sharkey. I oversee Spinnaker's supply chain consulting group, focusing on both the business side, business and management consulting side, as well as systems enablement. My background is working across a variety of different industries, helping companies kind of implement supply chain transformations, often with a fairly heavy technology bent. And co-presenting with me today will be Jeff Barrett. Jeff, give you a minute. You can go ahead and do a quick intro.
Thanks, John. Just want to say good morning and good afternoon to all of you out there, and thank you for joining our webinar today. One of the things that I wanted to bring up that John may have not covered is the fact that we see a lot of these implementations where JDA has maybe even thrown in or made you available to you the sequencing tool where people don't even know they own the rights to that tool, and that's another reason we wanted to get this out there in front of you and hope that you look at that as well with your JDA contract. A little bit about myself. I spent about 30 years in different shop floor places, primarily in the consumer products and food and beverage industry. I tend to focus on the JDA and SAP solution framework areas and have done multiple implementations of both of those tools.
Great. Thanks, Jeff. All right, so kind of a quick overview of what our goal is for the agenda, or our goal is for the webinar, as well as a quick agenda. So what we're trying to go through today is kind of a thoughtful and educational discussion of how sequencing fits into an integrated and closed-loop planning and execution process. So there will be a little bit of kind of upfront background and theoretical stuff that I'll go through. Then Jeff will spend some time talking about the sequencing capabilities and the benefits, and kind of talk you through how the sequencing solution works. And then I'll come back and wrap it up and talk a little bit about how we typically work with companies to adopt the sequencing solution. Okay, so here on slide 4, we've got kind of an end-to-end process framework, which is typical of frameworks that we build and use as a baseline to work with many of our customers. And you'll see kind of, sequencing sort of fits in down. Typically, it's a weekly process or a daily process, taking the output of the master planning process and turning that into a detailed sequence of activities that will occur across the shop floor. The connection, one of the key outputs, other than sort of directing the manufacturing activities, is for companies that use, ATP or order scheduling solutions. There's a portion of the horizon where sequencing will be providing information for order fulfillment, kind of the details on when product will be available. One of the key things we have to look at as we're talking about kind of end-to-end supply planning processes is which processes and which solutions are owning the schedule in different horizons. And for sure, the durations of these horizons can be different depending upon the industry or the physical supply chain that the company is working with. But typically, you have kind of a longer-term master planning window. Inside, a frozen time fence, at least from a planning perspective, the the scheduling solution will take over and have the ability to sort of create a more detailed schedule. And then at some point, that schedule is released to production, and it's frozen for both scheduling and master planning purposes. One of the things that I think companies have found as they've adopted advanced planning solutions is that really having a good handoff between these processes is really critical. Oftentimes you'll hear companies that spend a lot of effort and time building a master production schedule, only for that to somewhat get lost when it comes to the execution and the handoff into production. You hear about plants doing whatever they want. You hear about the difficulty in trying to implement an infeasible master production schedule. So scheduling well really helps kind of close that loop and close that gap. So we've got a few slides to kind of talk about why is scheduling so hard and some of the basics of kind of the scheduling problem. So one of the first factors is that there's fairly complicated supply chain considerations that need to be considered in a scheduling process. There's multiple stages of production. You can have different bills of materials, but perhaps depending upon different routings. Costs can be different depending upon the equipment and machinery used. You have to deal with things like cleanup and preventive maintenance, and then you have constraints in terms of when resources and when labor to run those resources is available. So it's a fairly complex supply chain environment that you need to deal with. On top of that, we layer a bunch of fairly complicated constraints. We've got to worry about material availability. Oftentimes, you have to deal with changeovers that are, in many cases, sequence dependent. And then you have, kind of the capacity from a machine and a labor perspective in terms of, how much throughput they can produce and are they available and how much is required to produce a particular product. One of the other problems that we have to deal with in sequencing is that because we are dealing with the sequence, we're not just dealing with kind of a time-bucketed master plan, which is typically what you can deal with for master production scheduling. The set of possibilities becomes large very, very fast. So just to give a quick example, if you had a company with 3 different products and you were thinking about all the possible sequences, there's six possible solutions, although obviously 3 is very few in terms of the count of the products. But what we've kind of illustrated down here at the bottom is that as the number of products grows, the possibilities, at least in terms of the number of sequences, basically blows up. So whereas you can solve other types of planning problems optimally from a mathematical perspective, sequencing isn't one of those problems that you can solve optimally. And so it becomes a challenging problem to try to come up with effective ways to get to a feasible schedule that moves you in the direction of what your objectives are and what you would consider optimal. Kind of the other consideration that goes into this is that when it comes to determining whether a schedule is good, there's a lot of different dimensions that we're worried about. So we're trying to satisfy demand. We're trying to, in some cases, maximize throughput or capacity utilization. We're trying to produce product in a low-cost fashion. And then we're trying to do all of that without massive buffers of inventory sitting before or after or on our shop floor. And in addition to kind of having all of those different dimensions that we need to worry about, these priorities change a lot based on business environment. So if my demand is soft, I might be, more focused, or if demand is soft or price sensitive, I might be more focused on service to try to go win business. Whereas if I have, more demand than I can handle, I might be maximizing the throughput in my factory so I can go satisfy that demand. And in many businesses, things kind of swing back and forth between those 2 different dimensions. And the scheduler's ability to kind of interpret what's going on in the business and translate that into a schedule that reflects those priorities is something that's really important. So part of the reason we're talking about some of these different topics is that when Jeff gets into how sequencing behaves, we're going to try to give you a feel for how you can pull those different levers within sequencing, and it'll react and generate a schedule that reflects your business priorities. So just a quick aside on kind of, manual and spreadsheet-based processes. So there's a bunch of different ways that companies deal with these problems today. I mean, obviously, without a scheduling solution and scheduling software implemented, there's still a way of turning, a master production schedule into things that are happening on the floor. So there's a variety of approaches people take. Many of them are good simplifying assumptions around, family-level scheduling or standardizing the sequencing or performing block scheduling. Sometimes those approaches, though, can go a little bit too far in the simplifying direction and basically, place some constraints on the supply chain. To give kind of a really quick example of that, a computer manufacturer that we were working with, when they went back and they were talking to the factories in Asia on how they could reduce their cycle time, the factory basically said, look, we produce rolling schedule where 1 week we produce for North America, 1 week we produce for Europe, and 1 week we produce for APAC. So they kind of had tried to simplify things with that type of block scheduling approach. And if you think about that from a cycle time and responsiveness standpoint, you're building in a bunch of lead time just to allow your scheduling to be easier. That can be for sure detrimental downstream in the supply chain. The other thing that happens as companies try to work through manual or spreadsheet-based processes is kind of simplifying assumptions around constraints or the supply chain model. So, a lot of times you'll hear, well, the material or the labor or the capacity isn't really a constraint. Or will approximate changeovers, will, in some cases, just give the master production schedule to the floor and let them operate. Now, all of these things can be, there's a decision to be made on whether the outcome of those processes is a good one for your business. But in many cases, what it leads to is, over-buffering and higher than necessary costs in areas like labor or materials or machine capacity. And on the flip side of that, perhaps limited responsiveness. The other quick comment is kind of on the technology side of things. What you typically see with spreadsheet-based models is it's really difficult to kind of collate and review and improve information. So just the nature of the spreadsheet model is that it has to be fairly simplified, and the ability to do kind of reporting and analysis on top of that is the challenge. Okay, so kind of coming back to, at a high level, why do companies implement scheduling solutions? There's kind of 5 different areas we call that. One is just managing risk. A lot of times there's knowledge captured in someone's brain. There's a risk that if the scheduler departs, all that knowledge goes with it, and our ability to run the business is negatively impacted. A major one, for sure, is kind of improving the quality of the schedule. So how can we understand what the constraints are and generate a schedule that's more effective than what a person can do manually? Another is improving the responsiveness. So, a manual scheduling process might take a significant amount of time. It might be the kind of thing where, the organization can only do it once a week, maybe, if possible. Whereas a scheduling solution can react and change and probably plan in a quicker and shorter time horizon. And then the last two are just sort of taking the planner's effort and really focusing on their exceptions and reducing their workload. So making it an easier task where they can really focus on the real business problems as opposed to kind of the rote manual tasks of building a schedule. So with that, I will hand it over to Jeff, and he will get into a little bit how JDA sequencing works.
Thanks, John. As we go through some of this, you're going to see that we've put together a process around where we believe sequencing should be going. I go back to one of the implementations we did where the CIO kind of came out and said, this is really what computers are supposed to be doing, is solving difficult problems. And that's exactly what JDA sequencing tries to do, and we try to set it up in a way that it will be repeatable so that that problem continues to be solved in a way that meets your needs as a business and meets the needs of the IT organizations. So the way we start with that is, in the sequencing world, we start with what's called a model. And that model is defined with a set of master data that brings that model together. And then from that model, we can look at multiple ways of inspecting that model or having that model actually execute through the use of algorithms. And we can get different approaches to the same set of data and make different objectives and priorities part of those algorithms, and then evaluate different schedules or different solves based on what those algorithms are put together to show. So what you see here then is a little 5-step process that really takes you through the ongoing piece of once you've got the model set up, once you've got your business objectives defined and how you want to evaluate what you're doing on your shop floor. Then you go into this ongoing use area where we repeat these 5 steps over and over again on either a daily or bi-weekly, maybe weekly. Look at how you want to see your schedule for your floor. And with that, you're updating your data, you're running your optimization, and getting an answer. You're reviewing that answer, then you may publish that answer to the shop floor. And to John's last point, now you can actually measure the results of how was that schedule against the execution that we did on the shop floor. There's a lot of real benefits that the JDA sequencing tool brings to the table and allows you things that manual spreadsheets don't, and that's a robust data model that will really reflect the real world. It also helps you to improve your schedule quality because you're now using some really powerful solvers to come up with what is the best approach based on the objectives that I'm putting in for my business or my goals, as John talked about earlier, when you're trying to manage all those different pieces. The other part of this is then it really reduces the manual effort. This provides really a user-friendly schedule board that we're going to look at here in just a little bit. It provides a way for you to have those people using a common tool. It's not just hey, I think it's how this formula was put into this spreadsheet, but I don't remember. It also standardizes your processes. As you see, we've got a nice 5-step process where we can go continually through, and it really makes that end user training a lot more effective for you. And then finally, it really creates that platform for you to do the continuous improvement. You can really start looking at and seeing things that are repeatable in your process or answers that you continue to get that may help you improve the accuracy of your production rates. You may look at pieces and decide that, hey, we need to work on specific areas of our business because our resource utilization isn't where we want it to be. We may want to look at reducing our changeover costs because we see that those have a large impact on our overall scheduling. Or we may even want to look at what the impact is of adding additional resources to our facility, or maybe even purchasing another facility and adding to our capabilities as a company. When I talk about the robust data model, you can really see it here that it really does allow you the ability to slice and dice up the information that you want to provide. And it also provides you the ability to put in just pieces and parts of this, or taking on the entire implementation of everything that you see here. And we'll talk about a roadmap of that coming up in the future here. But you can take everything from items and changeovers, calendars, capacities, production rates. All those kind of pieces can be put together in the model and allow the solver to come to a solution based upon what you've given it. And it doesn't require that all of these pieces be here. It just gives you the robust ability to consider all of them if that's what's needed in your implementation. So one of the key things here is, how does this solver really work? What is the black box magic that this solver, or what JDA calls an optimizer, work? And it uses a process called simulated annealing. And for those of you that are aware of the steel industry or the glass manufacturing industry, this is a process by where you heat something up and then cool it off and see if you got what you wanted. Then you heat it up again, cool it off, test it, and see if that's what you needed. So as it's doing that process in the algorithm, how we're using that in the JDA sequencing tool is around scheduling and generating a schedule and then determining, do I have a good enough schedule or a better schedule than I had before? So the first thing that the sequencing tool does is it initiates a feasible schedule for itself. It puts out one schedule that it randomly generates, and as it generates that, based on the objectives that we've set for it and the scoring that we've assigned to each of the pieces that we find to be important within our schedule, it grades that schedule. Now, this is just like golf in the fact that we want a lower score being a better score. So the optimizer, the solver, then goes through and continues to look at what are some things I can do better to make this schedule score lower. So it begins to use what JDA calls some generic perturbations and some heuristic boost perturbations to look at ways to improve that schedule. And as it goes through those steps, it continues to score them and bring out what it thinks is a better schedule each and every time based upon the objectives that we've provided for it. And then based upon some random probabilities, there's also some improvement that's selected that, it asks the tool once in a while to just go outside the box and give me a completely random answer and score that and see if it is better or worse. Now, of course, as we're doing this, this is all trying to circle that drain of getting down to the best schedule possible for us. And with the solver, with the optimizer, as John mentioned earlier, with the proliferation of factorials, there are innumerable amount of opportunities for it to improve the schedule. So at some point, since we probably don't have this running on a supercomputer, we need to be able to shut off the solver and say, I'm done, and I've gotten a good enough answer. So there's a couple of ways we can do that. We can do that over a max number of time. We can do that over a max number of perturbations and iterations of the schedule that we've taken. Those two are the primary ways that we want to shut the solver off to say, I've reached that point that is a good schedule. And those times vary and those numbers vary depending on the complexity of your implementation. We've seen solvers that run in 2 to 3 minutes. We've seen some solvers where we've had to let them run a half hour to an hour, just depending on that complexity. So what are these objectives we're really trying to balance? These are the things that we have to get the business to buy into before we ever go into trying to implement a JDA sequencing tool or any of these sequencing tools that are out there. You want to be able to determine what is it I really want to take on for my facility. Am I trying to minimize my late orders? Am I trying to reduce the total cost of my production? Am I trying to produce small sizes than larger sizes? All of those things have to be decided so that each of these has one of those perturbation boosts that we talked about on the previous slide available to us in the way that we score our model. And so it's really a question of which one of these do we want to do. And we'll caution you as well that you don't want to try and do all of them at once, because trying to balance all of these things at once will really produce a schedule that is hard to understand and may not be optimal really for your facility. So you want to focus first on a couple of these, and then as you learn your way around the modeling capabilities, start adding some of these other objectives and priorities into your solution. So I'm going to talk a little bit about what does a solver really look like. What does the optimizer look like when it runs? And this is a real screenshot from an actual execution of the solver in sequencing. What you'll see here is the red line up there are the multiple attempts the solver is taking in each of its iterations to score how did I do on this iteration of my schedule based upon my orders and based upon all of the business objectives that you had given me. Well, what was that score? And that red line, again, shows us currently where it's at. The blue line says this is the best score I've attained so far. So what you can see is in the beginning, there's a lot of red lines up at the top, fairly separated from the blue line. As we move through time, you can see that the red line starts to line up with the blue line, and that's where we're really starting to circle that drain and get close to a, quote, optimal answer for our schedule based upon the solution and the solver. And so then it becomes a question of when and how do I shut that solver off so that I don't have it run forever and ever. Because once we get to the right half of that graph, you can see the red and the blue line are basically on top of each other, and hasn't found a better solution in a long period of time. So it's probably about time for that solver to stop. And as you go through the process of implementing the sequencing tool, this is one of those steps that you have to look at and make determinations over how and what's the best way to run my solver. So I want to spend a quick couple slides here just showing you what the scheduling board looks like. We talked about being a very robust tool and a very user-friendly visual tool. What you see here is the actual schedule board that probably 90% of the time your scheduler would be spending looking at for what they're going to be doing within a given day, week, whatever time frame and horizon you've decided within your company that this would be your frozen period of production and the orders that would be made. So what you see across the top there is there's a set of filters and scenarios that let you bring down the schedule board to something that is usable for you. In this one, we happen to bring together a grouping of 6 machines that are all like machines. So we filtered it down to those 6 machines. You can see across the timeline that we're covering about 3 days in the way we're looking at this picture right now. Over on the left, you can see a list of each of those 6 machines or lines, whatever you've determined to be your resource. And you'll see a list of those on your left-hand side, along with a really nice Gantt chart in here that provides you a stretched out visualization of when an order is going to start and when an order is going to end. The other piece that you'll see here, if you look in the right-hand side, you see kind of a large green bar in there, and that's where a changeover has been determined. So the schedule, as it was going through and we had set up changeovers between products, it decided that that's where it's going to implement the changeover. The amount of time consumed for that changeover is there, and it goes on to present to you the item before and the item after. The next piece of that schedule board that you can see in there is there's really 3 different pieces in that Gantt chart. There's what sequencing calls the initial conditions. These are the released orders, the orders that are probably already on the machine and functioning at the time that we ran the schedule, because you will have orders that you are actually producing at a given time when you start a schedule. You then have the planned work orders, which is those new assignments coming into the schedule. And like I spoke about earlier, you see the changeovers as well in here that break up the line as to the difference, the amount of time required to switch from product A to product B. So again, that schedule board really is the basis for everything that we said the scheduler would do. And one of the things we want our scheduler doing is being able to see, are the competing objectives that I've put together getting prioritized correctly? Do I really want, I really want to put together the ability to make as many orders as possible on time, but I also want to make as many orders of the same color together. So, those are really competing objectives, along with another one here that I may want to ensure that my labor is fully utilized, but I want to reduce the number of changeovers. And, if it takes me 2 people to do a changeover, I may want to be able to reduce how many of those I'm doing, but I still want to make sure that my labor is fully being used, even though I've cut those down. So that's where sequencing really allows us some extra abilities to go in and view our schedule in multiple ways. It allows us the ability to look at the same schedule, maybe with different lenses. So I can look at it on the schedule board one way, where I'm seeing the schedule and looking at it by work order priority. And I may also want to look at it by groupings of the similar jobs, or maybe I'm bringing similar sizes together, things like that. I may want to view it that way and see how the schedule is working. And then, as I spoke about very much at the beginning of my part here, we have the ability to run different solves and set different objectives. So now with the same base set of orders, I may want to run multiple iterations of my solver to see it in different ways. And I may want to look at that through just one lens. And we've got a couple examples of those coming up here. So as you look at this, this is really the same schedule being looked at through different lenses. When you look at this schedule board, you can see here that we've got 6 lines of schedule, and I duplicated the picture, but they have different colors. It's the same orders, the same amount of run times. Everything is the same in that aspect. The only thing you see here differently are the colors. And this is where we really start talking about being able to view it in different lenses and the ability of that scheduler to identify, have I met the business objectives to the best of my ability? So if you look at this, the top one is really showing you the schedule based on my order priority. So you can see I really want to run my blues, which are the things that are currently on the system. Then I want to run my greens, my yellows, and my reds. So in the perfect world of a schedule being run by work order status, I would see blue, then green, then yellow, then red. As you can see here, when we look at line 2, you see a yellow kind of stuck in the middle of 2 greens there, which on the surface doesn't look like it's done everything correctly. So then we go look at another lens at the bottom down here. And in that bottom lens, what you're really looking at now is this being the product families are now the colors. Okay, so we've coded the same products together that are that have the same color or the same size or some attribute about those orders. And what you'll see then here as we look at line 2, you can see that our gold or yellowish colored item there is really the same color or the same size of product that we're running together. So what the optimizer decided is it was more important to keep everything of the same size and color together and to postpone that one green order off just a little bit past the changeover and complete the yellow order that you saw on the top. So this is really where the optimizer, the schedule board, provides a differentiation for you to be able to view those different objectives and created a schedule that is of value to the organization, both around the business objectives and around the ability to produce at the plant in the way that the plant wants to produce. And then the last piece here, we can look at and decide, now that I've ran those schedules, I may have ran those with one set of business objectives, like I said, around work order priority and looking at the groupings together. I may have also wanted to run another set of schedules that said reduce the changeover time. And I may have run another set of schedules that said make sure I stay within the shift patterns of the facility and how they're going to be open. So I may have 3 completely different sets of schedules against the very same model of data. And the other thing here that the sequencing tool really provides for us is these performance metrics around those different scenarios and helping us decide which is the best, really overall way to look at my schedule and to determine based on the objectives where things are. So what you can see here is when I look at this one, my solve 2, when I look at the stacked bar graph, probably is my best approach. Now, I don't know what solve 2 was in this very specific example. Maybe it was to reduce the changeover cost. And so then we would look at that and say, you know what, our changeover cost did reduce when we ran that model from 25K to 22K. I should be looking then at that specific schedule board to make sure that my business objectives are still being met. And at that point, you're ready then to release that schedule to the plant floor, let them execute that plant schedule, and then measure against how they executed. And hopefully in the end of that, you see the entire 5-wheel process that we talked about earlier here with the way that the sequencing tool works. So at that, I'll turn it over back to you, John, to talk a little bit about how implementations go.
All right, thanks, Joe. So just kind of giving this at a high level, I'm going to talk about kind of the typical phases in an implementation and then some of the key call-outs, during the different phases. The one thing is that the duration for these projects can be a pretty wide range depending upon, how complicated the supply chain that we're trying, or the production processes that we're trying to model are, and then how much data is available. So we kind of think about this as a 4-step process where there's the deployment planning, scoping, and design activities up front. To clearly important to sort of identify a good business opportunity, refine the scope, and then really think about this as kind of a crawl, walk, run type of journey that you would go through. And I'll talk a little bit about what that typically looks like on the next slide. The next step is around building that initial supply chain data model that Jeff talked about. That's typically done via integration. If you use other JDA solutions, a lot of this data is perhaps there, and then there's going to be some data that's sequencing specific that will be required. And like any good consultant, I think we would prioritize or prioritize not underestimating the effort around collecting and cleaning up and making sure that you have good data. The next step, and this gets into kind of what Jeff was talking about around how the scheduling algorithms would work, would be, one is kind of understanding what the business policies and objectives really are, and then working on the algorithm to standardize a set of rules that come up with good schedules. And, going back to the last slide that Jeff talked through, there can be kind of a set of nested or prioritized strategies that get defined. So, first try to satisfy all demands, and then try to minimize changeover costs or group wide products. And you can set up kind of a variety of these different generic strategies or priorities in kind of a standardized way, but it takes some time to kind of work through, looking at different options and trying them and seeing what in the end comes back with a schedule that's good for the business. And then finally, launching the solution and proving the business results. The nice thing about this is that it's pretty easy in many cases to kind of compare the legacy processes with what's coming out of the solution. And if you have a good kind of knowledgeable cooperative user who's being enabled by the system, we'll start to see things that, this is matching what I would expect it to do, or it's kind of taking what I had as intuition and very quickly turning that into a good schedule. And then, I guess for our brief commercial, skilled Spinnaker consultants help speed up the time to results as you go through this process. So finally, kind of the last quick section we'll talk through is, kind of from a crawl, walk, run perspective, what does this typically look like? So the first, generally speaking, it's best to, pick a limited number of resources and products, fairly simple business objectives for the algorithm, get things up and running, and start to learn and use the tool. If you kind of move into the walk phase, this is where you would expand the model in terms of, more resources, more products, thinking about kind of prioritized algorithm setups like I was just talking about for different business needs, adding more complex, constraints and supply chain modeling, so things like an attribute-based changeover matrix, and then more complex, multi-step production models. So a lot of times in the crawl stage, we'll still kind of use some of those simplified supply chain or assumptions like I talked about earlier. So really focus only on the bottleneck. But then as things kind of expand, you can add complexity around that, or maybe, model multiple bottleneck stages if the bottleneck is moving, that sort of thing. Then as you kind of move into the run stage, you get to the point of, adding even more complex constraints. So more multi-storage, multi-stage, more multi-tiered build bombs, different cost models for different routings, those sorts of things. And this is probably where companies start to do a little bit more advanced kind of what-if analysis around, okay, so I'm going to start to use the solution to help me plan my maintenance schedules and when I do it. Start to look at what I would call sort of site-level capacity planning at a more detailed level, and take this model and kind of expand it beyond the core scheduling mission to help address and solve other business problems. All right, so I think we have about 2 minutes to spare. So just as a quick wrap-up, if there's any kind of more detailed questions or anything you're thinking about that you'd like to bounce off of us, don't hesitate to reach out to either Jeff or myself. And with that, I hope everyone has a great day, and thanks for spending 45 minutes with us. Take care.